I would like to preface this before I show you the actual thing is that, it's based on what I would call as an outdated system, which is the Macagian system. And that was developed in the 60s and 70s. And I'm not saying that it's not valuable. It has been sort of improved vastly and put into what we now know as the geographical information systems, right? So GIS is basically an offshoot of what Macag developed as a series of ideas. And while it is quantitatively perfect as of now, qualitatively it is lacking highly. And when I say qualitatively, I mean what do the people experience? What do the flora and fauna feel about it? And several things have been written about this. The issue at the end of the day is, we are not talking about something static. And the problem with this system is that it is static. It does not take into account what changes are happening over time and how these changes are going to affect what the thing is. So what I'll show you today also is static, but we'll keep doing discussions of what the dynamism is in it and how that dynamism can also be sort of affected one and understood, most importantly. So in landscape architecture, I have felt over all this time that I've worked or taught, the main concern is not that of expertise. Landscape architects have a lot of expertise, but the concern is that of transferring perception or, explaining what you do. So to this end, the thing is that what landscape architects do is so complex at certain times that simplifying it becomes a big issue. And how does one simplify things that are basically beyond the understanding of the general public? So that is not something that is there in this study, but I thought I'll just highlight that that is equally important, because by the time we start looking at the technicalities of the study, we will realize that, well, but how do we explain it to the end user? And when I say end user, I'm not just talking about a person on the road. I'm saying even, people who are designing cities, let's say planners, bureaucrats, ministers, all these people are involved, and they need to be explain these principles in a very, very simplistic format. Now, unless you are able to do that and also explain the benefits of using these methodologies, unfortunately, it will fall flat. So there is a dual problem that one has to solve, and I'm just going to talk about one part of it today, which is the technical part of it. Okay, so let me start. Okay, can you see my screen?
Yes, sir.
All right. So, what really happens when one is looking at a settlement is when you're talking about historical settlements that, maybe before the industrialization, there is a sort of a balance between natural resources and a settlement, right? And this balance, one is because obviously the number of people in that settlement is very less compared to the amount of resources in that area, which is a generic thing. Even in, semi-arid or arid areas, the settlements naturally tend to be based on the size of resources available. The next settlement will be proportionately away, right? So if you read the work of, let's say, Tim Ingold or Jared Diamond, you will understand that there was a natural tendency for pre-industrial people to perceive how much resources are available in their settlement, and basis of that perception, the spacing between the settlements and the way these settlements happened would also work out uh, in a very fluid manner, right? So this is very important to understand that people before the industrial age had a very innate knowledge of what are the resources in their area, what is the dynamism of those resources, and how those resources can be utilized for their survival. Now I'll say survival, not lifestyle, because those are two very different things. Okay. But what happens when the settlement starts increasing, which is in the industrial age, because you had a lot of growth, is that you start borrowing resources from areas that are beyond your domain. Okay. So you start importing stuff from around the world, you start importing stuff from other regions. and you're creating these relationships which are not within your sense of what a region would be, right? So your resources deplete very fast, and this is not something that is again, this is not a pre-industrial example by itself. This has been documented even in places like Harappa and Dholavira was an industrial city of that time, and Dholavira used extensive firewood from the surrounding areas. Of course, it was semi-arid at that time also. It was not like a lush forest, but whatever firewood was available, they ran out of it very quickly. And of course, with the other geological changes that were happening in that area combined, they realized that it's not possible to take up this industrialization anymore. So the settlement was not destroyed by flood or something. The settlement started waning out very slowly because there was not enough resource available, right? As of date, we can import from around the world, so we don't have that thing, but we have one world. So whatever is the limitation of the planet earth is becomes what it is. Another important thing that you will see at a difference between this and this diagram is unusable wastes. Now, this is a typically industrial problem. In the pre-industrial era, there was no such idea. There was nothing like unusable waste. Everything was primarily organic, nothing synthetic in that sense. And you could, even if you just dumped it, it would disintegrate. And again, one, the proportion was very less, but secondly, it could disintegrate, and it would mix back with the soil or with whatever was there around it, right? But with these synthetic objects happening, and it's not that they don't disintegrate. Like we know plastic would take like what 10,000 years to disintegrate, right? So it's a matter of time. The time frame and the volume are just too high for the natural processes to take over, right? And even as of date, we can reuse plastic, but we cannot disintegrate it through any other means, right? So there is this talk of ecoplastics and so on and so on. But if you read the matter on it, you will realize that it's not worth the sort of energy that goes into creating those things. So these unusable wastes become big problems for the settlements, and that becomes something that the settlement is unable to solve. Now, again, I'm saying this from 13 years ago. As of today, we know that places like Sweden, places like Japan are able to, I mean, Sweden, as far as I know, is able to recycle more than 100% of its waste. So it's actually importing waste for its industry to work, right? And Japan has maybe 70-80% rate of recycling. So there are ways in which one can look at this, but if you're talking about a developing country like India, then it is a problem that one has to look at. And you come to the third stage where you've completely exhausted your region, right? And you're borrowing things from regions that are far beyond. So you're borrowing things from the global scale. So if you look at China today, other than rare earth minerals that are specifically available in China, it is borrowing from all across the world. If you haven't read, then you should know that China has agriculture in Africa, it has agriculture in South America. Uh, all the areas where countries are not developed, it is setting up large infrastructure to feed its economy, not just people but economy and lifestyles, right? So the settlement sort of becomes too big for its own subsistence in that sense. The unusable wastes become big, and the whole cycle becomes toxic in several different ways. So this is very, very important for one to understand at the basic level. And I mean, of course, my diagrams are archaic, but if you look at the work of OMA, they've done a similar thing for Rotterdam, where they've mapped the metabolism of the city completely in terms of energy flows, in terms of all the resource flows, in terms of manpower flows. All of that they've mapped, and they've said, well, what is Rotterdam, how does it function, and what is required for Rotterdam to keep functioning over a period of time. So these are important questions that landscape architects and architects or planners are addressing on a daily basis. And the context in this is what the work I'm going to show you here. Also, if you have any questions, please stop me and ask at the same point. I can obviously go back later, but just in case. So this is the region that I'm going to talk about. I had worked on Ahmedabad and its surrounds, and the question was, well, can you develop a strategy for expanding the city of Ahmedabad in a way that it does not hurt its resources any further, because it already has, right? So the baseline map or overlay that you're looking at is geological largely, right? And that, so Ahmedabad is unique in that sense compared to all the other cities because it lies at the junction of several geological strata, and it allows me at least to do this kind of analysis in a much more broader format, because then I can talk about several geological strata. But if you're going to look at a city which is more or less general, then you would only have one kind of strata, and then it becomes even more difficult to do a finer study in that sense. So I'll come to the strata later, but just to show you in reference. And to zoom in, this is what it is, and I've marked these distances in terms of sort of 25-kilometer grids from the city, and we had sort of decided to take a frame like this, where one is looking at Ahmedabad and its larger codependent or cohabiting area in that sense. So here we have something called as Null Sarovar, which is a very unique geological and physical system. And on this side, all the yellows, of course, it's geologically different, but it's also one of the richest agricultural areas in Gujarat, which is called as the Charotar area. So that's there. The area between Nal Sarovar and Ahmedabad is again part of this geological system, so it's highly saline, and it has. You can see a distinct difference in agriculture between the western banks of Sabarmati and the eastern banks of Sabarmati. And then there is this northern area which is like a regular sort of area, and you have the city of Ahmedabad in the center and the river Sabarmati. Another interesting thing is that Sabarmati is not one river, it's a system, so that you have all these other rivers sort of coming through and joining the river and creating these. I'll explain what they are later. But there is this system of land processes that is alive. Of course, it's working at a very different time scale than ours, and it is dynamic. And how do we sort of start looking at all this dynamism that is happening in the city? And the overlay that you will see obviously is this dense city of Ahmedabad, the highways, the railways, everything that is anthropological, that is overlaid onto this system. And if you'll see, obviously there is no sensibility in the way in which this overlay has been put. It's all just random, right? So can there be a relationship between these overlays, and how does one start looking at this sort of a relationship? Uh, Now, when we start talking about geology, we need to also understand how this area developed, right? Because, like I'm saying, Ahmedabad is at this junction, and that is also strategic because historically this junction was the bridge to several other areas, which I'll show here probably. So this is how Gujarat has moved through several ages, and how the relationship between the sea and the land has happened. So in the Eocene, if you see about 60 to 40 million years before present, a lot of this part was sea. So Ahmedabad probably was also in the sea at that point. And Saurashtra and Kutch, if two big parts of Gujarat, were independent islands. Of course, this sea was low-lying sea. And then during the Miocene, it started joining, but again in the Pleistocene, it sort of, because the ice age had melted away, and the water levels had risen. This happened. The last era was the Holocene, about 20,000 to 5,000 years before present. The island started surfacing. The sea started. They didn't start surfacing. The sea started receding actually, and this is what is the area of Nal Sarovar that you see, and the Kutch. So the Great Run of Kutch is very different from the Thar Desert in India. The Great Run of Kutch is actually a low-lying flatland. It's not a typological desert that one would imagine it is. So it's like a salt land. Okay, and that is a real boundary. So if you were to drive from Ahmedabad towards Rajkot or Kutch, these are very much visible physical boundaries which take you like almost an hour to cross, several times. So these boundaries are what define the location of Ahmedabad. You would imagine this is Ahmedabad, and before Ahmedabad was the capital of whatever the Sultanate was here, it was Patan, which was slightly northern here. And this island is Dholavira, and Lothal was also somewhere here along this thing. So this low sea was a good sort of enclosure for all the seafaring movement that was happening. So the ports were all around here, and that's how these cities came to be. And in present day, obviously, there is only a relic of this low-lying area, but the cities tend to be where they are because of it. So now, technically, of course, one has to see that, well, does it affect us in any different way? And this is a sort of a graph that shows what has been the difference in precipitation, the difference in surface temperature over the last 150, okay, it's supposed to be 150,000 years, right? So if you were to read this in detail, you'll see that there are several geological processes that have happened. So this is a mud flat which was there about 125,000 years ago, which you can sort of figure out somewhere here, right? And then there were braided streams that were happening in floodplain areas. So so the Aravali's eroded, right? This entire filling, what you see after the sea receded, is because of these streams, Sabarmati and all its tributaries coming from the Aravali's and depositing a lot of soil and silt here, right? So that's the process that happened over these larger periods of times. And then if you read this in detail, you'll know that there are many sub processes which you must have been taught in geology, like sheet washes and aeolian deposits and so on, and incision into the riverbeds. But most of the processes are in the last 10,000 years, if you look at it this way. And that's what defines the character of Ahmedabad. Now, vis-a-vis, if you see the temperature, which is the red, has had a drastic change. Between today's baseline of 0, it has moved between 4 to 8 degrees down and not up, but mostly downside, right? So because it was cooling during that time, and if you look at geological time scale, we are going towards the hotter parts right now, and that's why we are at 0. But the general trend is, if you see upwards, the precipitation has varied a lot. It has varied between plus 30% and minus 30 or 20%. So if you say Ahmedabad has 800 rainfall, it could have very much have been 1100, which is as good as the Dangs, a lush area, or much lesser, which then would go into Kutch territory, right? So there has been this huge variation, and that variation also tells us that whatever we are seeing as a system of land today is not static, and it is bound to change in several different ways. Now, we don't know the long-term changes because we don't even have enough data to talk about these changes across the world, but we have some basic information on where it right. So another thing one has to do is to cross-relate these things, right, with what people were doing during this time. So this is like a cross relation which says, well, during the last glacial maxima, which is about 120,000 BC, which is the timeline that I was telling you, we were generally more humid than today. And there was a lot of gravel load that was happening. And that allows us to see that that particular layer in geology, how does it work? There was the marine deposition, aeolian deposition, what were the kinds of soils, and what were people doing at that time, right? You had the first settlements that were happening. So I'm not going to bore you with all of this, but you see there is a very chronological movement of how people have responded to changes in all the physical systems. And till recent history, it was completely true. I mean, this is from 100 AD to about 1200, 1500 till 1800, before industrialization came to India. All these relationships were intrinsically linked to what was happening geologically in that area. It's only after this sort of thing, when people were not dependent directly on geology, when you had enough prowess to get water, get all the resources from elsewhere, that the disconnect happened. So this is where the disconnect is. The last 100 years, geologically, it doesn't make a lot of difference, but one must know what the disconnect is, right? And then this is also something that talks about that historically how the cultures have moved through time, and what has influenced the region that we are talking about. So, well, this is Ahmedabad. Again, this is 13 years ago, and today, of course, it has expanded much further. But one can see a chronology of expansion of the city, and this chronology becomes very, very extreme in the near years rather than the older years. The older years, it was limited to this much, but it has suddenly exploded out, and it has exploded on both sides. So, there is no logic to geology or terrain or any such thing. Now, what is also happening very importantly here, when one has to look at this, is that we are borrowing water left and right because the city cannot sustain on its own resources. So we started with Khari, then Shady, then Mahi, where all of these places we are borrowing water. And that was not enough. So we are starting to borrow water from Narmada, the Dharoi Dam upstream, all of this just to subsist this city of what I think 70, 80 lakhs today, right? That is one. The other issue that I was saying, wastes. Everything is pushed downstream, including solid waste, liquid waste. So this area is so polluted that there are special studies being done of this area, that what is the kind of disease load or disease burden that is happening in the people, the animal, the kind of agriculture that is coming up. And obviously, sarcastically, one could talk about it that all the agriculture is being sold into the city. So, yeah, it serves us right, but it's a real problem that Ahmedabad is polluting its downstream to an extent that it may take thousands of years to remediate this over a period of time, right? So this is very, very important for one to understand. Now, one obviously moves on to what landscape architects do. Talk about all the physical layers, and this is geology, where I will start with. Again, I put these overlays so you can see that there are no strong relationships of the overlays with the geology. But the geology itself is very, very interesting. So this light yellow is the alluvial plain, and that's where all the rich agricultural area is. The oranges are the sand sheets. So it's the aeolian deposition that has happened over a period of time. Again, it's fairly good agricultural area, not as rich as the alluvial plains, but well, it can do well. And there are other parameters also related to water extraction and everything, which we'll discuss as we go ahead. There is a slight amount of basalt where the Aravalli's tips come out into this area that we've chosen. And then there are conglomerates, which is somewhere here and somewhere here, which is, if you remember, I was talking about sheet wash and depositions based on that. And a large area to the west here and some area here is mud flats or tidal flats. So this is very poor agricultural area. This is very poor in terms of even soil drainage. I mean, if you go along this highway in monsoon or this highway in monsoon, you feel as if you are crossing the sea because the entire area is flooded with water for months together. No agriculture is possible, only subsistence agriculture is possible, right? So this is very, very important to understand. And of course there are oil fields here, so that's a rich oil area for the ONGC. So this is the kind of, you know, dynamism that just the land has in terms of geology. And Ahmedabad obviously ignores all of it and just moves ahead left and right. But when you go across these areas, I mean, you have to see these areas to know how it is. I mean, between this and this, you can see a drastic difference in the way these areas are. And just by looking at the kind of flora, fauna, whatever is growing there, you know that this is a very, very different area. And if you ask a structural engineer, they will also say that yes, it's very difficult to make foundations in this sort of area versus very easy foundations in all these areas, right? So there are several parameters that start becoming linked to just one parameter of land and how the city is, expanding, or what could be the best way it can expand in that sense. And of course, we also have to talk about soil. So there are several parameters again, and this is just cover and texture. So the yellow one, again, the richer agricultural area is fine loamy soil, and the orange one is fine soil. This one is coarse loamy soil, and then there is some loamy soil somewhere else. But generally, you could say that the area is good because you have loamy soil, except again the mudflat area which has fine soils, which are not so good for agriculture, right? And then the depth of soils also becomes important. So again, one will see that these are shallow soil areas, whereas these are more or less deep soil areas in that sense. And then one also has to talk about the drainage of soil. What are the issues that one has to look at? So you'll start seeing a pattern here based on just one geological base. You can start predicting patterns. Again, this is all on the eastern side, well-drained soil, and then you have towards slightly on the northern side, moderately and excessively. So where you have the sand sheets, you will have excessively drained soils, and that becomes logical because it's sand, right? And all the east western part and the southwestern part becomes imperfectly drained or badly drained soil. And all the problems also start happening here. So you have soils that may have sodicity, salinity, calcium content is high because it was from marine deposits. All those sorts of points will start coming up in this. So the geology is actually giving us baseline understanding of soils, but you can obviously talk about this more and look at it. And there are these several small studies that one looks at between relationship between root growth, percolation, soil moisture, flooding, and responses of different kinds of soils that one is looking at. And then one has to say that, well, I've studied this so far, but let me get a perspective on what it tells me, right? So just basis of soils, if one has to come up with a relative suitability of, what is a good area to do what kind of thing. And then our aim right now when we are assessing this is to just look at development. Can you develop the city here, right? And this is the kind of thing that comes up because if you start looking at all these things, you're looking at the depths and texture and drainage, and then you're coming up with a figure that looks like this, which says that okay, you need loamy to fine loamy soils for one, agriculture, and second also the development of the city. And as you go towards fine soils, it may not be so suitable for several purposes including foundation design, right? So that gives me a general character of how the city is looking now. So very commonly I see that okay, along the riverbed, slightly difficult. There are these areas geologically that are suitable, more or less in certain ways. And then there are, I mean, the western area obviously is not suitable for development. It is an area that is going to have several kinds of issues for whether you want to do agriculture or put up an industry or put up this development of the city. So several things need to be considered when one is doing expansion in this part. And then you add geology to it, right? And it becomes more complex. So what was a very broad area here starts becoming a finer area here. Now, of course, these are maps that are developed in very, again, archaic techniques, manually, Photoshop, and so on and so on. But you could do all of this simplistically in GIS based on numerical mapping. So I'm sure they must be teaching that to you. But in essence, the thing is about the idea and weightages, not about which software or tool you use to develop this, right? So what is this now? And there are several relationships that are now starting to develop here. So there are relationships between soils and geology and resource zones that are starting to come up, right? So these relationships now start to tell me that these zones, if you see this one particularly, from most suitable, lightest yellow to least suitable, which is the darkest brown, I start seeing a pattern across the sheet. And this pattern is important for me. There are sub patterns within this pattern which tells me, okay, maybe better area here, but worse area here. Maybe better area here, but worse area here. And I can make judgment calls. Now, this is something that Mekhar talked about, but he talked about very lightly. And I think that was one of the things that should have been emphasized. That at the end of the day, after doing all of this, you have to make a judgment call on what does this pattern tell me? And as a landscape architect, what will I deduce? So, if this is the best area to develop on the eastern side, should I develop the city on that side? Or is this the worst area in terms of agriculture? It may cost me more, but then should I develop the city on this side because it is not taking away prime agricultural lands, okay, which are needed for food security? And it's a confusing question because I mean, you obviously know this area is prone to flooding. It has difficult foundation. The salinity itself affects the way the steel, in the foundation works, and even in terms of earthquake, this is an unstable area. This gives you everything, but this cannot grow food. So what do? You will have to make that sort of a judgment call and say, well, oh well, this becomes very confusing for me, right? So this is the sort of thing that I was looking at, and between these relationships of depths and texture and drainage and issues and all the different geological types that were there, one would come up with most suitable areas in sand sheets and alluvial plains, and then slightly less suitable and less suitable. But the non-suitable areas or least suitable areas would fall between the mudflats, basalts, and sometimes in the sand sheets. This is just based on two parameters right now, geology and soils. And we need to talk about several more parameters, right? So let's talk about water. Now, Ahmedabad and its surrounds, obviously, particularly has an issue. Like I said, we've run out of water. And what you're seeing here is a groundwater hydrology map. And the lowest level, which is this, is about 50 meters for tube wells, right? And these levels 13 years ago were 120 meters. Now they are easily up to 250 meters or 300 meters of depth. So you're drawing water from almost half a kilometer depth and you're using it. Now, this is a cross section of geologically, I'm sure you've been taught about aquifers and aquitars. So these are several layers, and we are probably drawing somewhere here right now. The thing is, it takes monsoon water a lot of time to transgress through these areas and come here, right? So there have been a lot of studies done in Ahmedabad, and whatever water we are using as of date is said to be probably between what I remember, I may be slightly wrong here, 20,000 to 30,000 years old. Okay, now 20,000 to 30,000 years that water has been in that aquifer layer, which obviously means it has reacted to the geology in that, and it has gained a lot of chemicals that one would not want it to have, right? Fresh water has very less chemical content. So we have problems of salinity, which is most obvious, hardness, but also fluoride. Sometimes we have lead and everything falling into the water. So it's highly unsafe to use that water. And the quality is very bad. So there is an added cost to filtering and purifying that water. And a lot of waste is also generated in that sense. So essentially, we've created a system that is toxic for its own good, right? And the way you see this, it's really bad, right? It's not worth mentioning. And of course, there is fluoride and nitrate poisoning that is happening in several areas that one is looking at. So even if you were to start recharging in these areas, it would take us, in the best of scenarios, thousands of years to gain sustainable water levels. And that's where we've reached today. So just basis of looking at this and the problems that are faced, one can start talking about areas that are suitable and not suitable for groundwater extraction, right? So something like this, just basis of these fluoride. So I'm just removing right now fluoride and nitrate issues, and I'm avoiding the deeper areas. And basis of that, I can come out with suitability for it. So these are basically simple weightages that one is giving. And I think I forgot to talk about the topography. So the drainage is largely from northeast to south, slightly tilted. And the western side obviously has no drainage. If you see, there are no rivers, there are a lot of ponds. But this drainage is not existing anymore because the land modulation has become flat over a lot of geological cycles. But the eastern part has very good drainage by itself. And then one wants to look at recharge potential basis of surface drainage, because monsoon is the only way to recharge to that scale, right? So where you have rivers, it's easiest to recharge within their riparian zones. That becomes first priority for us and very crucial because we are running out of water. And then the areas with sand sheets become easy, because if you remember, I was talking about excessive drainage in those areas. So sand sheets become the next areas where you want to drain. And then you talk about the other areas that are there slightly. But the worst area to drain is obviously the mud flat. You will not be able to drain into that area, right? So that's how the general sort of thing comes. So if you go back to what we are talking about here, very suitable for development, but very critical for rainwater harvesting and drainage. Water is subsistence. We've not invented water by ourselves. So very crucial in terms of that. So now it adds another layer of confusion to our judgment calls and says, well, now what do I really do with this city and where does it develop? Does it start encroaching and making nalas out of all these streams and killing them up? Because then you can't, I mean, a city is basically an impervious surface, right? It will not be able to recharge anything. So this is like the detailed sort of view of how the weightages were done for this area. Of course, that was before the era of this. So the groundwater board has now come up with what is called as groundwater prospects map. These are available for most states in the country. This one is for the same region. So this is Ahmedabad. I did not sort of uh, stitch it together, but this is more or less similar. They have similar rules that we have, not very different. If you see, uh, again, they are using the same techniques that I'm using, and you're talking about the geological layer, the geomorphology of it, depth to water, and then what are the prospects of groundwater, and then they say, well, what kind of recharge structures are best for this area. So now this is a ready reckoner that is available to you to do all these kinds of studies, right? And yeah, sorry, it's here. So depth range of wells, hydrological information, structural information, all of this is given in a groundwater prospects map that is here. And if you see the way it is done, it's all the same. It's exactly what we would have thought it to be like, right? Not different at all. So yeah, this is just an example of how these techniques were used. And then one needs to talk about vegetation, because vegetation, so vegetation is one of the most dynamic components. It can come and go as quickly as human life. And one has to understand this. We may think that plants are soft and we need to take care of them, but they are very, very sturdy. At least not the nursery ones, but ones that are found generally along the roadside or in wild. They will become to the point of invasive as quickly as within a few months if you don't stop them, right? So again, you have to understand that you only have to question whether you want to allow space for them to grow or not. They will do the rest of the story. You don't have to worry about what they will and will not do, right? So just to give you an idea of what I've been talking about, these are differences as seen in photos. So alluvial plains, sand sheets, and mud flats. How do rivers look? Okay, this is within the same time frame. Okay, how does roadside plantation look? So you'll see, lot of diversity changes that are happening. How do the fields look? Again, you will see patterns are very, very different. And how do fallow lands look? Right? So these give you, I mean, just by observation, you can start telling what is the richness of the soil, what is the kind of soil, whether you see accumulation of water. You can start predicting the typologies of this, right? And one has to then start talking about what is the climax one can achieve. So if you leave the place to be what it is, what is the maximum you will achieve? You will not turn everything into a tropical forest, which is what the Miyawaki guys want to do, but that's not practical, right? You can't do that. You can't have enough water to use for our uses and then to water the plants, right? So dry deciduous forest is the maximum one can reach, in Ahmedabad and surroundings. Several areas are such that you can only have grassland ecologies in those areas. And you can have thorny scrub in these mudflat areas. You will also have marshy areas somewhere. And then you will have open forests or dry thorny scrub forests. So there are these several climax possibilities which are there for a lot of this areas in Ahmedabad. Now, I'm not saying that you convert it, but I'm saying what is the possibility and how do you assess it. And then one comes and says that, well, what about this geological history that I studied? and what is the ultimate possibility or direction in which this place may go in the next, maybe 5,000, 10,000 years. Not that one is worried, but just as an idea of assessment. And then one talks about something called as climax. So the climax tells me what was the climax in an earlier era that was possible. And then this is obviously from data. There were no maps right at that time, so a lot of data, and this is a sort of an imagined climax based on. So the data was based on if this kind of geology and this kind of climate, then this is what you could expect, sort of data. So based on that, one again says that, well, what one imagines here to be a lot of farmland and dry deciduous forest, actually this was all grassland and dry deciduous forest. And this was slightly better because it was thornic scrub rather than being an open scrub in some sense. And the marshes were more extensive. There was open forest also in some of these areas. Yeah. So this is, even historically, you cannot go much beyond this. So this is the best case scenario, right? And that's what is the limitation one has to look at when one is doing such things. So then one comes to the composite resource zoning. So all these layers now have to join together, and I don't have the Excel sheet because we didn't have, I mean, we were not so conversant with GIS during that time. So we used Excel sheets to solve these sort of problems. So there were several sort of variations done, and those were discussed with a lot of people, and which one sort of tended to be the most accurate. Again, it was a judgment call, like I said. Starts becoming things what you want it to do, right? So this is a map. If you just absorb it, I've tried to make it as color coded as possible. But what it actually does is it creates these sort of zoning ideas. And this is very, very typically Macagian, right? It's static, like I was saying. It does not take into account the dynamism of these places or how people will relate to these places, right? So zone one is conservation. You do not want to touch it. You want to use it to conserve as much water, as much groundwater recharge you want to do. So you can do regional parks or plantation buffers or institutional areas in places like this. Zone 2 then becomes area for, again, it's as good as the zone 1 for conservation, although you could say that you would have more parks and institutions in those areas, or you would have non-intense suburban, sort of thing in those sort of areas. And then zone 3 is one step further than that, which says that, well, maybe you don't want to conserve entirety of zone 3. You want to use it primarily for non-intense and suburban uses or agriculture or things like that. Yeah. And zone 4 then starts becoming your usable or development zones, right? That is where you will have intensive development or suburban areas. Zone 5, zone 6 are all variations of zone 4, right? They will start following more and more intensity of development areas, right? And I've given these photographs for all of these for references in that sense. Now, zone 7 becomes the area where you are saying, well, I want to develop everything, but there are several problems because this is a mud flat area, and there are several parameters that one has to look at. So you could have either grasslands or plantation buffers, or you could have cash crops so that you're not eating those crops, or you could start developing industry in that zones, right? So that's how it starts going. And then zone 8 again is similar, zone 9 to a lesser extent, like zone 7. And then you have these other three zones which are not useful for any development. So you have the marshland, which has to be grasslands and plantation buffer, no development in any sense. Flood prone area, which can have some sort of suburban development, but mostly it's just plantation, and you use it for that. And then you have the polluted area, which needs to be revitalized. So you could have industry in that already polluted area, but not a polluting industry. You use the industry as a base to generate enough economy in the area to sort of regenerate or revitalize it, right? So now that you have some idea of these zones, and you start seeing these zones across, so all the blues become more or less untouchable areas, right? Again, I'm not commenting on the current state of the economy, so I know there are several land processes that are not sort of matching with what this is, but like I said, the main problem is how do I explain this? The perception issue is very big. I cannot tell somebody that, oh, northwest of Ahmedabad, stop developing anything. You need this area for groundwater recharge. They'll say, okay, then put more groundwater laws, but let us develop what it is, right? So that level of finesse is not there in this project. But one starts seeing what is important for the survival of the city, and then one starts seeing, well, what are the low use zones, what are the moderate use zones, and you can start saying that, okay, maybe these are the areas where the city can put more effort into developing, and that would be better. And then these are also the peripheral areas where things can start developing with, like I said, riders. You'll have to take care of several things and do it. And this area to the south, more or less, is the polluted area. So you need critical interventions in that area for any kind of development, right? And then one has to imagine what will the city look like. So this is an imagination. This is not at all any sort of development. So, yeah, I think I'll have to give you the legend first, right? So the lighter color is agriculture, and then there is contract farming and cash crops, and then there are these institutional areas, low density, high density development, right? But what it essentially tells me is that there is hardly any place left for Ahmedabad to develop. It is critical at this point in time to allow areas for other kinds of development. This area is more suited for agriculture than any other uses. This area is more suited for cash crops than any other uses, and Ahmedabad is just stuck in the middle, right? So the best probable areas that are available are here north of Gandhinagar, slight area to the west, which is here. But other than that, practically you are encroaching on land uses that would have been better served by other systems. But if you also read the fine print, the project proposal also talks about connecting the lake systems, and these are existing drains. I did not make them. These are all existing seasonal or ephemeral drains, and also creating what one is usually taught. All these buffer systems and everything, but also leaving large swaths for groundwater recharge. If you remember, this was the area where one was talking about the best quality recharge happening in the sand sheets, right? After the obviously riparian buffer edges. And this is a system that one needs to treat on its own, because you want to sort of develop it, but also want to look at problems and solve them as you go along developing it, right? So then one I mean, these are obviously by graphic standards, these are laughable and in today's date, but in that era, this is what we could do, right? So these are standard typologies, again, how you would develop what. But like I said, again, these are figurative rather than and prescriptive. These are not considering the practicalities of the situation. And then one talks about how one looks at water management and everything and so on. So yeah, I think this should be it. Not sure. Yeah, this is it. This is it. So yeah, that's about it. And I can stop presenting. Yes. Questions, please.
Very insightful presentation, Sandeep.
Thank you.
Thanks again for sharing. I think it covered each and every aspect in so much of depth. I'm sure each one of them would have already understood what their lacunas in their present processes are. So you all can share any questions that you have.
Good morning, sir. Prof here. So it was a very insightful presentation. But the question that I wanted to ask was that, like, just finishing now, you talked about um, that this land is more suitable for this kind of a development, but they have not been utilized in the manner that it should have been for the appropriate land use. So, do you think that we as a landscape architect could, other than giving a proposal or something else, that can be resorted to resolve this issue at hand?
So do you mean you? I'm sorry, I don't follow it exactly, but let me know. So you're saying, can landscape architects develop proposals that can resolve these issues? Are you saying that?
Yes, sir.
Yeah, so frankly, no. I'll tell you why. Because, see, this is something that requires multidisciplinary input. Even when I was doing this, I was talking to several planners, several urban designers to be able to do this. And a lot of issues I know, even in that day and time, were not captured. Right? So, in isolation, nothing is possible. But you would ideally have a team that looks at several parameters, and then one has to find their way through everybody's requirements and come up with a balance. This is idealistic at best.
Okay, sir. Thank you.
Yeah.
Good morning, sir. Sir, I would like to ask a question. As you mentioned, the western part of the city that was not suitable for any kind of development. And sir, you also mentioned that it wasn't suitable for agricultural development, neither agricultural nor any kind of infrastructure development. So, sir, in that scenario, what should we do about that land? Like, we cannot leave it barren and let it decompose away. So, sir, in that scenario, what should we do about that land?
Right. So again, like I was saying, see, the physical planning is what we can understand. But if you're going to say that, well, let's talk about economically what is going to happen as a value of the land, then it's a very complex question, because one has to answer it in several different ways. That, well, what is the future of Ahmedabad? Does Ahmedabad have a master plan for its growth? I mean, economical growth. And if it does, then parts of that, whichever do not require that sort of stability or that sort of, either land richness or whatever you would call it, could actually be housed in that area, right? I'm not particularly saying that it should always be a grassland or something like it, but grassland in absence of saying anything else. And we know that generally, in Gujarat, there is a dearth of grassland. There is not enough fodder available for, we are very rich in terms of the sheer number of animals that agriculturists have, but not enough fodder. So we were in fact thinking at several times that maybe this becomes an economy in itself, where you are packaging and exporting fodders to different parts of the state, right? But that is obviously the lowest kind of economy one can imagine. At the highest level, you can imagine industrial areas to be coming in that area. But again, these are ifs and buts and can only depend on what really is required for the city's growth. So it's a very complex question. Physically, one can attribute 5 or 6 things that could be done in that area.
Okay, sir. And sir, one more question. Like, I don't know if it is relevant or not, but I wanted to ask like about the confined aquifers. You mentioned that confined aquifers, it gets recharged in like 2000, 3000, or something up to 10,000 years also. So, sir, in that case, when we want to draw water out of that area, it becomes decomposed and like in a deteriorated condition. We cannot use that water. So, sir, what is the use of a confined aquifer in the long run? How can we utilize it? Like in present scenario, there are water crisis over many places, so we cannot use that water also. So, sir, what is the use of confined aquifers?
Yeah, I mean, so you're asking a sort of a question that says, well, if I do not have water tomorrow, will I drink cyanide if it is available in liquid form? You obviously do not want to drink cyanide, right? It's bad for your health.
Yes, sir.
So there is no answer, right? Now, confined, you have to take it in context. Now, I was saying confined at the level of 10th and 12th aquifers from the ground level, not the first and second. The first and
Yes,
second
sir.
have more frequent recharge characteristics, but at the 10th and 12th level, the recharge becomes very, very less, right? And anyone in their right mind would never take or use that water. But if you don't have anything, then what do you do? And that's the problem we are solving, right?
So, sir, by extracting the water from that region, it would require a huge amount of like money to make that
Yeah, so
water
Ahmedabad is
safe.
spending that money. We are spending money to draw water from 300 meters and then purify it
Yeah.
to RO level. So yeah, there
Yes.
is no option.
Okay,
But
sir.
nobody see, the problem is, like I said, the problem is that of perception. Earlier, before the industrial era, you would actually go to the source of water, look at it, and then take water from there. So you would know if it is polluted, if it's tank or whatever. You're getting water in a tap. You don't care what is the amount of energy that is required for that water to be purified as of date, right? So it's like ignorance is bliss sort of situation where you're just going with the flow, but you have no plan to know whether the water is going to last you another 10 years or 50 years. So in context, if you see Singapore's plan, Singapore till very recently, or at least till 2025, it's depending on Malaysia to give it water. But it has come up with a very, very strict water regime where it says that every drop of water that falls on the top of your building has to go into a rainwater tank, and you have to use that water first and the public supply later. And the costs are also put accordingly because they know a very small country, which is an island, you don't have enough water for all the people living there, right?
Yes, sir.
So it's a matter of perception.
Okay, sir. Okay, sir. Thank you, sir.
Yeah.
Good morning, sir. So my name is Shanpreet.
Hello, sir.
Yeah.
I want
Thank
to
you.
ask. Okay.
Okay. Maybe Devina, you go first.
Okay, sir. I want to ask you. You have shown a large area as polluted area in one of the map, which is on the downside of Ahmedabad. So I want to ask, sir, is that is a entire landfill or it's a regional area that is very much polluted with villages and settlements?
So they are polluted in several different ways. There is a landfill to the south of Ahmedabad, which is leaching into the groundwater, which is leaching into the land. But also the industries around Ahmedabad are sending untreated waste to the southern parts because it's downstream, it's easy. There are a lot of natural nalas that are available. Now, all that toxic waste through the soil, through the water, and on the surface, all three, starts leaching into the land that is there. So over a period of last 40, 50 years that severe industrialization has created this, the land is practically unsuitable. You can't even stand in that area. It stinks and the chemical quality is full of lead, arsenic, and several such chemicals that are leaching from the industries.
Okay, sir. Sir, then what are the strategies that you thought of to deal with that kind of an area? Because that is generally any metropolitan city has that kind of a part.
So frankly, I did not because the requirement of the project was different. It was talking about development, but you would have to look at a project that looks at remediation of polluted lands to, see those sort of strategies.
Thank you, sir. Thank you so much.
Yeah. Yeah, there was.
Yes, sir.
Yeah.
So thank you for sharing a knowledgeable presentation, sir. I was also asking the same question. So you have divided different zones and you have then divided the flood zone, the marshes and the polluted land. So you have given the answer what is polluted land. So if we have a polluted land, we need to conserve. So why didn't we put that into the conservation zone or any other zone?
I'm sorry, I don't follow you. What was the
Sir,
question?
so we have divided zones like the zone one is the conservation zone, and then the less suitable zone or the degraded zone can be used as density zone like residential. And you have also divided the polluted zone. So I think polluted land also need to be conserved. So why didn't we put that into
Okay,
the
okay, okay. No, no. So it's mentioned as a special category because it cannot fall under the regular zoning criteria. But the comments that are given for this actually talks about conserving the, first revitalization of the land, which is not the same as conserving the land, right? So you need to do active, you need to put in place active techniques so that the land can be revitalized. Conservation and preservation would mean just leaving most things as it is and doing minor changes here and there. So there's a drastic difference in the way one would approach land management.
Okay, sir. Thank you, sir.
Yeah.
Any more questions? Thank Thank you, Sandeep. It was an extremely insightful presentation, and the students could understand how layers could interact and how, as planners, we can see then the implications of the resources for settlement planning. So thank you so much again, and I'd like to invite you for the to see their future work, which they are
Sure.
in the process, which is in the ongoing state right now. So in the coming few weeks, we'd like to invite you for the same. Thank
Absolutely.
you so much, Sandeep, for coming us in such a short notice
No
and
problem. Yeah. Thanks. Thank
interacting
you.
with our students.
Yeah. Bye bye.